Okay. Good morning, everyone. As usual, any questions before I start? So today I'm going to pick up what we did yesterday, where we started yesterday, the idea of a power series, which is a good way to look at it is as a generalized idea of a polynomial. It means polynomial have a certain degree. So I talk about polynomial of degree 3. It means the highest power of x in the expression is 3. Polynomial of degree 4, it means the highest degree of x is 4. Power series, you can think of them as polynomial of infinite degrees. And we're going to study them for two reasons. First, some functions will be given to you as a power series, what we're going to talk about on Monday. And the second thing we're going to study about them is that we're going to show that every function that we know can be written as a polynomial of infinite degree, meaning a power series. So that's are the two ideas that we're going to get to eventually next week. Now, the only questions we're asking ourselves is the following. So we have a power series. It means we have a series that involves a variable x. And our concern is for which x does the series converge. And what we did yesterday was we say, okay, we're going to use the ratio test. So I will pick up where we did. And we computed the limit of the ratio between the absolute an plus 1 and the absolute value of an. And we got yesterday 3 times the absolute value of x. So the ratio test tells me that tell me which value of x I can plug here and I have convergence. So the ratio test tells me that the series will converge, so that's from yesterday, when my ratio is less than 1. And now I want to see if this quantity is less than 1, where is x? So basically I isolate my x. So if x in absolute value less than a third, it means x has to be between a third and minus a third. So we know that it converges right there. So I always draw the number line just to a little bit give us a picture. This is 0. And it means it's basically, I know it converges right here. Now, where is diverge? And as we did yesterday, diverge outside. It means when the ratio is bigger than 1, and that's give me when x is bigger than a third or x less than minus a third. So right here, we have diverges. Right here, it diverges. So that's where we stopped yesterday. And now the question is, what happened at the endpoint? Does it converge or diverge? Remember, and that's important, at the end point, it means if x equal minus a third, the ratio will be 1. So let me plug it back here. If I put x equal minus a third, this ratio right here is going to give me 3 times minus a third equal to 1. It means the ratio test at x equal minus a third actually will have to fail absolutely. So let us see what happens x equal minus a third. How do we treat the endpoint? So I say, okay, now endpoint. I mean minus a third and a third. I'm going to take each one of them and figure out what happens. So if x equal minus, let's start with x equal a third. What happened? How do we know what happened? We're going to take x equal a third and plug it back for x in the expression of the series itself. So I'm going to plug a third right here and ask myself, what happened if x is a third? So that's exactly what I'm going to do. So I'm going to plug a third in the expression of the series. So this expression of the series is sigma 3 to the n xn over square root of n plus 1. I'm going to put a third for x. And we're going to simplify. That's really the trick. So that's 3 to the n and instead of x is 1/3 to the square root of n plus 1. Now, of course, this looks like a complicated expression. That's why we need to simplify this a little bit. And can we simplify it? What do you think? Let me take this piece right there. This is equal to what? On chat, can anybody see this is equal to what? Anybody can see? This is 1 to the n, which is what? Which is 1. Exactly. So let us do it very, very carefully because you will have to do that a lot. What's 3 to the n times that? That's 3 to the n times 1/3 to the power n. It means 1 to the n, if you want, over 3 to the n. So that's where my algebra is kicking in. 3 to the n, 3 to the n, they'll simplify, and this expression is exactly equal to 1. So this gives me that the sum is basically nothing more than sigma 1 over the square root of n plus 1. So if x equal 1/3, then I plug it back into this power series. I have a series of numbers now, which is 1 over the square root of n plus 1. Now, does this series converge or diverge? What do you think? I want answers, and I want answers. Does it converge or diverge? Quick. Diverge. Anybody? Adam, converge. Okay, so when I have contradictory answers, we have to know what's the solution. Converge. All right. Why it converges? Jordan, in mute and justify.
Would the numbers be getting close to 0 as n approaches infinity?
Does this mean the series converge?
Not necessarily.
Exactly. Exactly. The integral test is going to show me that the series diverges. Okay, so not necessarily. The term have to get, that's why we have test. If when the term become close to 0, the series converge, we will not have to do all those tests. The reason we're doing all this because it's when the term become close to 0, which is in this case, the term actually become close to 0. So like let us say, I don't know where n started, it doesn't really matter. So basically I am adding this plus that plus etc. That's really what I am adding. The term do become small, but does it mean that the series converge? We have no idea. We have to use one of the appropriate tests. Okay, which is the test that will tell me whether this series converge or diverge? Or this series is what actually? If you guys look at it carefully, this is what? Do you see anything look like it? That's a P series, absolutely. That's a P series. Almost a P series, where the P is a half. Definitely diverges. So having the terms go to 0 tells me nothing about the series. It may go either way. That's why we're learning all those tests. Now I know that the series diverges, so I know that it's going to blow up to infinity. There is no way out. All right, so now we're going to take the other endpoint. So my other endpoint right now is the following. So the other endpoint is x equal -1/3. And my question is, does it converge there? Again, I'm going to plug -1/3 into the expression of the series. And I'm going to see what do we get. Again, at this stage, algebra is in order because this is really a nightmare expression. So the numerator now, that's where the mess is. Let me take care of it. So what will I have? 3 to the n minus 1 to the n over 3 to the n. This cancel. I will have minus 1 to the n. So this is going to leave me with minus 1 to the n over the square root of n plus 1. Now back to you. Does the series converge or diverge? What do you see when you see the series? I'll give you a minute to answer the question. Okay, converge or diverge? I have one answer. Okay, absolutely correct. The minute I see this series, I should see an alternating series because I have minus 1 to the n. So when I write this up, I'm going to write it up. I'm going to have as n is 1 minus 1 over the square root of 2 plus 1 over the square root of 3 minus 1 over the square root of 4 plus minus, etc. This is the type of series I'm going to have. So this is absolutely an alternating series, absolutely an alternating series. And the terms of the series are, the absolute value of the terms are 1 over square root of n plus 1. And definitely the terms go to 0. So the first piece of the alternating series is satisfied. Second, the terms are decreasing. As n is getting larger, of course, those positive piece of the term are getting smaller. This is decreasing. So by the alternating series test, a lot of time we basically simplify it to that, series will converge. Okay? So this is what happened at the end point. Now, a remark before I move on. If you plug in x equal minus a third, and you get a series, and at this point, you use the ratio test, you're going to get 1. If you don't get 1 by the ratio test, it means you're doing something wrong. So at this stage, you should not be using the ratio test because this is the value where the ratio doesn't give me any result. So at the end point, if you feel that you want to use the ratio test, and if you use it and you get something different from 1, then what you're doing is wrong. So no ratio test at the end point because that's when the ratio is equal to. So now let us sum up. Where does the series converge? So now the series converges when? For x between a third and minus a third equal to minus a third because it converges right there. And the interval of convergence, so because a lot of time we talk about the interval, so the interval of convergence is the interval closed at minus a third, open at a third. And finally, one more word, we talk about the radius of convergence. The radius of convergence, it means your interval is right there. That's minus a third and a third. This is included. The radius of convergence is the distance from, in this scenario, from 0 to a third. It means that's what we call the radius of convergence. So the radius of convergence is a third, is half the length of your interval, which reminds you a circle. The radius is from the center to the edge. And that's the radius of this interval, from the center of this interval, which is 0 all the way to 0. So this is where my series converge. So it means that if I pick a value between minus a third and a third for x, I am fine. Anything else, the series will diverge. All right, now we're going to take one more example along those lines, and we will also analyze it. So for those, all the notes are on Blackboard, so it's very clear. So example number 2. Okay. Example number 2 is the following series. Sigma x to the n over n factorial. N equals 0 to infinity. Okay, so this means, I mean, I don't always have to write it up, but sometimes I like to write them up. X plus x2 over 2 factorial plus x3 over 3 factorial, x4 over 4 factorial, plus so on and so forth. So the question again, which x's will be allowed here to guarantee that this series converges? Which number for x can I put? Can I put 1? Can I put 2? Can I put 3? And I have conversions. Okay, we have one tool in our hand, which is the ratio test. So I'm gonna take, sorry, an, it's xn over n factorial. And an plus 1, it's x to the n plus 1 over n plus 1 factorial. So always the ratio test. And I'm going to compute the ratio and see what happens. And the values of x allowed are those that makes the ratio less than 1. So the ratio for the ratio test tells me that you can apply it whether series has positive terms or negative terms, it doesn't matter, but you have to take the absolute value of the two. That's what the ratio test tells me. So let's compute this. So that's the limit. As n tends to infinity of, okay, an plus 1, as I did yesterday, when you take it in absolute value, it's going to give me that, over n plus 1 factorial times n factorial, because we're going to flip the an, over x to the n. So let's give me, this will give rise to the what? Limit as n tends to infinity of, I put like terms together, times absolute xn plus 1 over absolute xn. So let's compute this limit. The limit. Now, this one we've done. N plus 1 factorial is n factorial times n plus 1. We need that to be able to simplify. So n factorial simplify, I will be left with 1 over n plus 1. Now, what about here? Absolute x to the n plus 1, we've done this. I can split it into absolute x times absolute to the power n times absolute x. Again, those will go away, and I will have the absolute value of x. Now, what's the limit of that as n goes to infinity? X is a number. When x goes to infinity, this is going to go to 0. 0 times x is 0. So what does this mean? What does this mean? Which is less than 1, of course. What does this mean, you think? So I computed the ratio, and I got it's equal to 0, less than 1, regardless what x is. That's important, regardless of what x is. What does this mean? This means the following, that regardless which value of x you put in here, 1, 2, 3, a million, this series will converge. No matter what you put, this series will converge. So this tells me that the series xn over n factorial for n equals 0 to infinity, this one converges for all values of x. Means this is 1 plus x squared over 2 factorial, x3 over 3 factorial plus so on. It will converge regardless what x is. And one of the things we're going to show later on in the course that actually the value it will converge to, and that's will be one of the, this is going to be e to the x. So we're going to show that the sum of those terms is actually e to the x. What am I talking about? It means if I plug in 1 for x here And I plug in 1 for x here. And I start adding those terms, adding those terms, adding those terms, we're gonna get the number E itself, which is 2.713. And we will show that even if I took x to be 2, e to the e squared, and I plug it in here, 1 plus 2 square over 2 factorial, the sum is going to be equal to e squared. Means no matter what x I plug in here, we're going to show that you're going to get e to the x. It's one of the most important results that we will see later on. But for us now, what matters is that this series converges for regardless what x is. And it means the radius of convergence is actually infinity in this case, because it converges for all values of x. And this also tells me something that I would like to emphasize. It also tells me that, here it is. If this series converges for all x, it means that if I take the term x to the n factorial, actually let me take, suppose I take x to be 10, then this is telling me that the series sigma 10 to the n over n factorial converges. What does this tell me? It means that those terms, if it converge, it means those terms, when n goes to infinity, will be equal to 0. If this converges, it means the individual terms goes to 0. So the question is, it means which series, what goes to infinity faster, 10 to the n or the n factorial? If the ratio of those is 0, it means when n is large, means when I start taking 10 to the power 100 over 100 factorial, 10 to the power 1000 over 1000 factorial, those terms are becoming very small. It means that which term go to infinity faster? This one or that one? Absolutely the n factorial. So the n factorial goes to infinity faster than the exponent. And even if I put 100 here, so if I added 1 0, I added a 0 here, it doesn't matter. Those will still go to 0. So the n factorial goes to infinity faster than any series, faster than any other basically function, exponent, power, everything. Right. Now we're going to take up the same idea, but we're going to talk about something called power series in x minus a. And so power series in x minus a is actually the same thing as power series in x, but instead of having x, we have a quantity x minus a. So power series in x minus a, so a is fixed. And power series in x minus a, it means a series of the following form. C0, but instead of x, we have x minus a. Instead of x, we have x minus a squared. Instead of x, we have x minus a to the power 3, and so on and so forth, where a is fixed and the constants are fixed. So it means in sigma notation that looks something like that, 0 to infinity. So that's a power series in x minus a. The first ones, we call them power series in x. That's really the difference. So for example, a power series in x minus 3, it means a series of this form. Instead of x, I have x minus 3 to the n, and here I have a bunch of coefficients. It doesn't really matter. This is example of a power series in x minus 3. And the question again, which x's can I put in here that would guarantee that this series will converge? All right, before I take up a problem and do it in details, who can give me one values of x that will make this series in front of you, whether inside the circle, converge? One. I don't want two, because it's hard for you to give me two. who can give me one value of x. That will guarantee the convergence. Anybody else? Absolutely, x equal to 3, because if I put in x equal to 3, I'm going to have 3 minus 3, which is 0. I'm going to be adding bunch of zeros, which is absolutely convergent. So that's really just tell you that at least for x equal to 3, it converges. So now I'm going to take up one problem and try to solve the following questions. For which x's does the series converge? So it's verbatim what we did before. Verbatim what we did before. The only difficulties we're going to face is the following. Okay, so let me make sure I explain that, and the rest would be actually simple. Suppose absolute value of x is less than 4. And I ask you, find all x's such that absolute x is less than 4. Okay, we talked about that. If the absolute x is less than 4, it means x has to be between -4 and 4. That's where x has to be. Now, suppose I stretch it a little bit. And I tell you, find all the x's such that x minus a number, first, 2, is less than 7. So I will do it algebraically today, and next time I'll give you a geometric intuition, what's really going on. How can I find those x's? All the x's such that x minus 2 is less than 7. Okay. The way we're going to do it is exactly the way we thought here, but we have to be very careful. So I'm going to change, no, well, how are we going to be careful? If this quantity in absolute value is less than 7, it means what's inside those brackets, this absolute value, this piece has to be between -7 and 7. This whole piece, this has to be. What's inside the absolute value has to be between -7 and 7. And now I am done. If this is the case, it means x has to be, I added 2 both sides, 9 and -7 plus 2, -5. Okay, so I'm going to do one problem, but this time I'm going to do it in a more general way. Suppose A is a fixed number, R a fixed number. And I ask you, find all the x's such that the absolute value of x minus a is less than r. Let's find that. Okay, if this is the case, what does this mean? If RA is fixed, R is fixed. It means this term right here has to be between R and minus R. It means x should be where? So this is my number line where I want to show you the solution. If I add A both sides, it means my x has to be between A plus R. So I'm going to put A right here. X has to be between A plus R. So from here to here, this is R. And A minus R. It means this is your A. I'm going to take R away. That's A minus R. It means X has to be, sorry. It means X is in the interval. It's inside which interval? It's the interval centered at A and with radius R. These are the values. So if absolute value of x minus a less than r, it means where is x? X is in the interval centered at a and radius r. And watch carefully, this really makes sense because if x is in here, suppose x, if I take any number here, x minus a, this is x minus a, is definitely less than r. If x is here, x minus a is going to be that much in absolute value, which is less than r. So if You are faced with the question, find all the x's such that absolute x minus a less than r. You can do it purely algebraically, so you don't redo any mistake. X minus a here, do it algebraically. But the way you're going to visualize it is actually, this is the picture. It means all the x's such that the distance basically to a is less than r. This is how we visualize this integral. Now, with this being said, the second example, which is, I will just highlight it a little bit and you guys will read it and do the homework, is the following. So suppose I ask you the following question. Let me take the following series, the one I just wrote a minute ago, which is n over 2 to the n x minus 3 to the n. And I ask you for which values of x this will converge. It's actually the same thing. You're going to compute the ratio of the an plus 1 over an. Okay? Just compute the ratio. And if you compute the ratio of this one, you're going to get x minus 3 here. And we're going to get 2. I think. Okay? We're going to get 2n plus 1 and 2. Sorry, we're going to get a half x minus 3. And then you're going to argue the same. You want this converges when this quantity is less than 1. It means when x minus 3, you isolate this, less than 2. It means, first I do it algebraically. It means x minus 3 between 2 and minus 2. It means x between 5 and 1. So that's how you solve that. And geometrically, what is x? Basically, if x minus 3 less than 2, it means x are in the interval, all the values of x, such that up to 3 you get 2. So this is my 5 and this is my 1. So that's the 2 and that's the 2 that you see. So this series will converge for every axis in the interval centered at 3 and with radius 2. And if you have any difficulties with this concept, I don't think you should, it means all the axes between 1 and 5. Now, the other thing we will have to do, and I will assign homework and I want to do them, is check what happened at 1 and check what happened at 5. So we can have the whole picture going. All right. So for Monday, I would like you to read the example I have in my lecture. So please read it very carefully and make sure you do the assigned homework, because we have to stop at this stage. Another point in order is that your exam is next Friday, exam number 3, and the review will be put out tonight. Okay, so good luck on your quiz and get going. The quiz is on Blackboard.